And welcome to Naughty Notes. Well, let's explore these next four theorems. We're going to we'll do a little bit of measuring. We're going to start here with this theorem 10.7. We'll take a trip from the known to the unknown. I want you to go ahead and take your straight edge and draw these rays. Now I know this makes angle C a central angle. A central angle, and we know something about that central angle. We know that it's equal to the measure of its intercepted arc. Now, we could measure this thing with a protractor. You could put it on there and give it a good measure. And what do you got there? Well, let's have a look. See what I've got. I'm getting about 102 degrees there. Move this thing out of the way. Because the central angle is equal to the measure of the intercepted arc. We already knew that. That's old news. Now, if I were to take this vertex and move it away, see that angle looks like it's getting smaller. And if we move it all the way down to here, it's going to change as well. And, well, let's just draw that and see what we've got there. That's going to be called an inscribed angle. And that's because anywhere along here, see that vertex D is on, see that? That vertex D is on the circle. So go ahead and give that a measure and see what you come up with. And I'm willing to bet if you really do a good job with this, you're going to find something amazing. I'm looking at there 40, 50. I'm getting about 51. Because in fact, we know this very simple truth. These two angles are related. And what we've got here is that the measure of the inscribed angle is exactly, let's fill in the blanks up there. The measure of an inscribed angle is exactly 1/2 the measure of its intercepted arc. Hey, 1 down, 3 to go. Okay, let's flip over to, or look down your sheet to 10.8. And now, I got an idea what's going on here. I want to draw these two. Well, draw these rays right there. And I'll go ahead and give them a measure. Now, I don't know what it's going to come up. I mean, yours may be different. 10, 20, 30, right, 10, 20, 35, 6, 7. It's looking a lot like 37 degrees to me. You may get something slightly different. So be honest and measure. Well, then we're going to draw these two rays and go ahead and give them a measure with your protractor. Notice a different protractor on this one. We like to mix it up. These are the old ones we had from HSGQE. I'm going to put it right there. And again, I've got 10, 20, the 30, 5, 1, 2, 37. So it's looking again like 37 degrees. That's what I've got. I hope that's what you get. And do get your protractor out and give it a try. Because in fact, this theorem is going to tell us this. These two angles. Now this kind of makes sense. See if I move it like this, well, they seem like they have to be the same because these two angles intercept the same arc. So we're going to fill in the words there. Two inscribed angles intercept the same arc. Then they are congruent. Now, let's have a little more fun with this because there's something else you probably see here. Now, that's it for the theorem, but make a few notes on this. I'm going to label this point R because I like R. And then what kind of angles you got there? Well, those would be vertical. We all recognize those. And what have you got now? It looks like I've got these two triangles, and they are, give me the S word, they are similar by angle. That's kind of neat. Notice they are not, definitely not congruent. They are similar. Look at this. All the chapters just come together. So we've got two more for this, for our little worksheet here, and we're just filling in the blanks on our theorems. 10.9. Oh, this is a fun one. And what we've got here, let's see. Well, I've got two different drawings for you. I've got this thing, I will tell you straight up, this is a diameter. AC is a chord, passes through the center D. Now, if that's a diameter, that means that this arc is 180 degrees. So is the other one. But I'm going to do this. I'm going to take a random point. I'm going to call it B right here. I'm going to take a random point, and from there, I'm going to intercept this green arc. Well, what's 1/2 of 180? Of course, it is 90. And see what's happening there. Now, you could even verify this. You could take your protractor and you could turn it on there and say, that sure do look like a 90-degree angle to me. So go ahead and measure and verify. And a little bit of fun here. You could draw another. You could draw another. All three of these, and as many as you could draw, they would all be right angles, and hence those figures right triangles. If we get a chance to do this in Sketchpad, well, you're going to construct that. And then the fun part is, of course, you can animate it, and it looks really cool. But that's the fun part of the class. That's the part I hope we get to. Let's see what we've got. So this part of the theorem in this direction says, if a right triangle is in a circle, then the hypotenuse is a diameter of a circle. Pretty cool. Now, how about if I pull out my compass? You might remember this from chapter 5. You remember constructing the circumcenter. And if we constructed the perpendicular bisector of these three, we had this big discovery where the circumcenter on a right triangle is in the middle, is the absolute middle of the hypotenuse. Well, we've already done that. So I left you this mark right here, right there. That's the midpoint of the hypotenuse. Put the needle, the compass there, and just give it a gap to any one of these. This is going to bring back memories. And give it a swing. Because, of course, I can now say this figure is inscribed in a circle. I can say if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle. Hey, that's pretty neat. Well, I think I had those two backwards. Sorry about that. But both of these are valid, nice drawings. And let's move on. Let's move on because why? Because we've got one more to go. Oh, this one's kind of interesting. And a lot of measuring for you on this one. And honestly, I don't know what it's going to come up, but I've got these. Now your paper is monochromatic, but I've got colors here, and I want you to imagine this. If you were to draw this ray, I'm going to call that the red one, and I want to take this F. I'll see what, and you could put that on there and give that a measure, and see what you come up with. What's that look like? 90, 100. Maybe 102. That's what I'm thinking. Something like that. So I want you to write these things down. If you got 102, write down 102. And then I want you to imagine this blue angle going this way. Now hang on just a second here. Remember, this 102 intercepts this arc. So this must be a major arc. That must be 204. Kind of neat. Remember that? It's half the intercepted arc. Now let's draw the rays here, and let's measure old blue. Let's put the needle. Put the needle on the D, and give it a spin. And let's line it up like this. And I don't know what we got there. 60, 75. It's looking a lot like 78. That's as close as I can see with my eyes. Now look what's happening. This is actually pretty cool. You notice something. You know that the red angle intercepts the red arc, okay? And the blue angle intercepts the blue arc. So that means that these two arcs, though, this arc and this arc, must add up to 360, a circle. However, the two angles, well, they appear to add up to 180. You know why? Because they do. And that's really because of this. It can be, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Pretty neat. Now hang on, I'm going to clean this up, and I want you to go this way. Oops, didn't mean to do that. How about if I draw this angle? I'm going to call this one the green angle, and let's put the vertex down. Let's put that vertex over here and rotate this so I can read that. And what do we got there? That's 50, 96. I'm getting about 96 degrees. Okay, again, the green angle is intercepting that green arc. See, I'm going to split the figure this way. And now I'm going to draw an angle this way. Let's measure that one. And it's a good measuring activity. Oh, come on, my simulated instruments. And you're so lucky because you have real instruments. They're so much easier than these simulated instruments. There. Let's hold it like that and see how well we can read that. And it's looking like about just shy of 85. Just shy of 85. I'm getting about 84. And heavens to Murgatroyds, we add those two together, we get the same thing. Why? Because again, these two arcs, this arc and this arc, make an entire circle. And therefore, these two angles have to add up to 180 because they're each half of their respective intercepted arcs. In the end, this is my quadrilateral, and both pairs of opposite angles are supplementary. Well done, Links. Now, I think you've got some other work on the other side of this paper, but I want to say thank you for watching Nani Notes.